although we don't have the database yet set up, we can, we can still like think about how do we handle this problem. Um, so like let's say we're running a database query where we are going to um, we're going to be looking for a user based on their email, and check if we can log them in basically. So that we have their email, we have I'll write it first like it was like Python or something. We have their email, we have their password, and we want to get back the I think in Python it's actually technically this. So I'll say that this is TypeScript here. So email and password, and we get back a logged in auth cred, or login auth cred, we'll call it, whatever that looks like. So how do we do this? We would first want to check if can we find the person by email, and then check their password. Yeah, so first we're going to search for a user based on email, and then we're just going to check the password. So password 1 equals password 2. The password passed in is equal to pass 2. And so how we would actually like write this in Haskell is that we would say, let's say we're writing this in Haskell as if it's like another language, and we're not aware of how either works yet. We're going to write login user, and this is going to be the type email and password, and it'll give us back a auth cred. So an auth cred, I'm going to use this type keyword just to make things easier to read. So this is saying that email is really just a string. Same with password. Password is really just a string. And auth cred is actually just their user ID. So we'll just call it an int for now. In reality, this would be like signed, like hashed, so that only they can dehash it. And that is actually how like any auth system works. Is just that you have some sort of like user identifier which is hashed, and only they can unhash. Of course, there's OAuth or whatever, but even OAuth is effectively just doing this under the hood for us. So, okay, we get our auth cred back. I don't know why I deleted it there. And great. Email, pass. And so we'll have our pseudocode here, which is going to say, so we're going to use do syntax, which just allows us to do like a bunch of actions in a row. And because I'm using do syntax, if you're not sure how to use do syntax to start with, like you probably want to use do anytime that you have IO here, and that's real safe for now. You'll understand that better as we get more deep into the discussion and the lessons. The lessons also do help you understand at a deeper level what we are doing with do and IO. But here, let's say look up user, and we'll take their email and some DB connection string, we'll say, and DB connection string is just going to be a constant that I've set that is equal to my local Postgres. So it's probably going to look like if you're using a connection string, it probably looks like this, or it's like Galen at my password Postgres. Then it'd be the port, and then my DB name. So I'm gonna call it this instead. So this would ultimately try and look up the user. Obviously, we haven't written the logic of how the lookup user works, but we will probably see that with Kyle's demo. Um, and so, what happens if this fails or succeeds? So, obviously, if this succeeds, we're all happy. You know, we have we get back a user and we're like, yay, okay, now we check password. Again, this is all pseudocode here. Check password, pass in user. So this is gonna just simply do this, where we have the password and the user. And so, yeah, I guess this will also just here. And so, like, you know, let's say our password is this, and we have our user, which we're going to use some Haskell data type. That user contains, like, for some reason, our user just has a password. So the string is representing the password, and actually I'm going to say user password because I can use this type I've defined here. And you know, and I guess we'll just say pass is equal to their pass. And then if that's the case, you know, if check password, this is actually going to be a bool because it, you know, because we're checking if it's true or false. If check password, then return their user. It else. Oh my gosh, this is so ugly.
By the way, Gillen, we're good to go on my end, so whenever.
All right. Yeah. I'll just finish this off here. Else, error. You failed. So, we have two things that can fail here. We look up the user, and then we check if the password is incorrect. So, basically, like, what this will, how this would currently work, like, if we could write this logic exactly in JavaScript, and it would say, yep, this looks great. And what would actually happen is, like, if this does not go to plan, either we cannot find the user in the database because maybe they just have never signed up, or we made a mistake. Our code is actually broken somewhere else, like the insert function is broken. Then this is going to panic. And if this fails, then this will also panic. However, what we can do instead is we can say that instead we can use either to model this better. So we have either error or authcred. So error will just also be a type of string. And we can instead say, instead of panicking with this error, and this is like a real Haskell function, you can use this if you, for some reason, want to panic, but you don't ever want to. You can then say, else left you failed. And this will be a way of modeling to the rest of your code that there has been an error, and I'm giving you the error message. Please pass this along. And then I'll say write user. So write, things went according to plan and went great. And the same thing would happen here, is that we then need to say case user of left error, and we just probably want to say like left error, like continue on with that, or it is the correct user, and we want to continue on with our logic. So this is semi-valid code here that I've written, and this is just a simple demonstration of how using either as a key concept for error handling, allows us to write safer programs. And so with Kyle being ready, I'll stop sharing there.
Cool. Thank you. Yeah, that I use either a lot in this code, so that'll help. Okay, so